everyone. Welcome to science class. We are continuing our exciting journey through the chapter, Fun with the Magnets. In this video, get ready to dive deeper into the amazing world of magnets, their powerful properties, fascinating uses, and so much more. This is Magnet Mania, Properties, Uses, and More. Have you ever played with a magnet and watched it attract tiny bits of iron? It's almost like magic, but it's really science. When you hang a bar magnet freely using a string, it always points in the same direction, north-south. This is called the directive property of a magnet. But why does it happen? This happens because the Earth acts like a giant magnet with a magnetic field. The magnet aligns itself along the Earth's magnetic field, just like a compass needle. That's why suspended magnets help us find directions. This directive property is used in a very useful tool, the magnetic compass. Inside the compass is a tiny magnet called the needle. This needle moves freely and always points toward the Earth's north magnetic pole. By knowing where north is, you can figure out all the other directions, south, east, and west. For example, when the needle points north, the opposite side is south, to the right is east, and to the left is west. That's how people like explorers, hikers, and sailors find their way, even when they can't see the sun or stars. The magnetic compass helps them travel in the right direction. Isn't that amazing? Can you make your own compass? Yes, you can. But first, you need to learn how to make magnets. You can make a magnet by rubbing a piece of iron, like a nail, with a magnet in one direction several times. This is called magnetization. After your nail becomes a magnet, you can float it on a small piece of cork in water. The nail will slowly turn and point north-south, just like a real compass needle. This way, you've made your very own simple compass, a cool way to see magnet magic in action. Now that you've made your own magnet and compass, let's explore some fun properties of magnets. First, like poles or same poles repel each other, while unlike or opposite poles attract. North poles push away other north poles but pull in south poles. Poles always come in pairs. Every magnet has both a north and a south pole. You can never have just one pole by itself. If you break a magnet into two pieces, each piece will still have both a north and a south pole. So, instead of one magnet, you now have two smaller magnets, each with its own pair of poles. The magnetic strength is strongest at the poles, so magnets attract objects most near their ends. Here's something cool. Magnets can attract certain objects even through materials like paper or plastic. This happens because magnetic forces can pass through some non-magnetic materials without losing much power. So, if you put a piece of paper or plastic between a magnet and a small iron object, the magnet can still pull it toward itself. Magnets really do have some surprising powers. Now that we know how magnets work and their special properties, let's see how useful they are in our daily lives. Magnets help us find directions with compasses. They keep fridge doors closed tight to keep food fresh. They make electric bells ring and power motors. Magnets help sort materials in recycling plants. Magnets are even inside the strips on credit cards and help trains run faster. In the medical field, magnets are used in machines like MRI scanners to help doctors see inside our bodies. Magnets are all around us, making life easier. But magnets don't stay strong forever. They can lose their magnetic power. This is called demagnetization. This can happen for several reasons. When you drop a magnet, the tiny magnetic regions inside get jumbled and don't line up well anymore, so the magnet becomes weaker. Heating a magnet gives energy to its particles, making them move more and lose their alignment, which reduces the magnet's strength. Hammering or hitting a magnet also disturbs the alignment of its magnetic regions, causing it to lose power. And if magnets are stored improperly, like near other magnets with opposite poles, they can cancel each other out and become weak. So, to keep magnets strong, it's important to handle them gently and store them correctly. Magnets can become weaker over time if their poles are left free. This is called self-demagnetization. To keep permanent bar magnets strong, they are stored between soft iron pieces called magnetic keepers. A magnetic keeper often has a wooden base with two magnets on either side, arranged so the unlike poles face the same way. Magnets are always stored in pairs and kept in opposite positions to help maintain their strength. For horseshoe magnets, just one piece of soft iron is enough as a keeper. Using magnetic keepers and proper storage helps magnets stay strong for a long time. Magnets really are fun and full of surprises. Today we explored the amazing properties of magnets, how a magnetic compass works, how to make and store magnets, what causes magnets to lose their power, and the many ways magnets are used all around us. Magnets may look simple, but there's so much happening behind the scenes: invisible forces, strong poles, and even demagnetization. Now it's your turn. Can you answer these? What happens when you break a magnet? Why should we not drop a magnet? Where is a magnet's force the strongest? Pause, think, or explore on your own, because learning is always better when it's hands-on. Thanks for watching, and keep exploring the magic of science.